Chapter 4 Strong Acid, Strong Base, Class Life Sciences. Part 1 Definition of acids and base and pH. At the end of this session, students should be able to define acids and bases according to Arrhenius, calculate the pH of solutions. Introduction. Acids and bases are important substances in health, industry, and in the environment. They play an important role in our daily life. For example, hydrochloric acid in stomach, acetic acid in vinegar, sulfuric acid in car batteries are among acids used in our everyday life. Java water in bleaches, sodium bicarbonate in baking soda, soap and household products are among bases used in our everyday life. 1. Definitions of acids and bases. 1.1 Acids. According to Arrhenius, a Swedish chemist, an acid is any substance that ionizes in water to produce hydrogen ion H+, but H+ associates with water molecule to form the hydronium ion H2+. Then, an acid is any substance that ionizes in water giving hydronium ion H3O+. For example, hydrochloric acid HCl. When HCl is in gaseous state, it is called hydrogen chloride. The green ball is the Cl, represents Cl, and the white ball represents the hydrogen atom. When hydrogen chloride is dissolved in water H2O, it produces hydrogen ion H+ is transported from HCl to H2O, and H2O it becomes H3O+. Then we obtain H3O+ and Cl-. This ionization of HCl, hydrogen chloride, then giving H2O+, therefore hydrogen chloride when ionized in water, when dissolved in water, it is an acid. There are monoacids, for example HCl, HBr, HNO3, that gives only one hydrogen ion. These are called monoprotic acids. And there are diacids or diprotic acids, for example H2SO4 that gives two H+ ions, and triacids like H3PO4. In this chapter, our study is restricted to monoacids or monoprotic acids. Now, base. According to Arrhenius, a base is any substance that ionizes in water to produce hydroxide ion HO-. Example, solid sodium hydroxide NaOH ionizes in water. Water here is a solvent to give Na+ ion and HO- hydroxide ion. Since NaOH gives HO- ion in water, then NaOH, the solution of NaOH is a basic solution. NaOH ionizes to give Na++ HO- in water. Then the solution is basic since we have formation of HO- ion, hydroxide ion. There are also mono bases like NaOH, KOH, sodium hydroxide and potassium hydroxide. We have dibase like calcium hydroxide, CaOH2, and we have tribase like aluminum hydroxide or iron 3 hydroxide. In this chapter, our study is restricted to monobase like NaOH and KOH. Classification of solutions by comparing concentration of HO plus to concentration of HO minus. Solutions can be classified as acids, base, or neutral according to the major ion. Acidic solutions, the major ion is the H3O plus ion. That means concentration of HO plus ions bigger than concentration of HO minus ion. Basic solution, the major ion is the hydroxide ion. The concentration of HO plus is less than concentration of HO minus ions. In neutral solutions, there is no major ion. The concentration of HO plus equal to concentration of HO minus. 3. pH. 3.1 definition. What is the pH? pH, the abbreviation of hydrogen potential, is the measure of concentration of H2O plus ions in aqueous solution, in diluted aqueous solution. What is the relation between pH and H2O plus ions, or concentration of H2O plus ions? The pH of a solution is the negative of the logarithm of HO plus ion concentration expressed in mole per liter. pH equal minus or negative log concentration HO plus. And therefore, the concentration of HO plus equal 10 to the power negative pH. These are the two relations. When we have the concentration of HO plus, we can calculate pH applying this relation. When we have the pH, we can deduce the concentration of HO plus by applying this relation. Remarks: this relation is not applied except for concentration of HO plus less or equal to 510 negative 2 mole per liter. That means for dilute solutions. The higher the value of HO plus ion, the lower is the corresponding pH value. The concentration of HO plus and pH varies inversely. That means when the concentration of HO plus increases, the pH decreases, and vice versa. When concentration of HO plus decreases, pH increases. Application 1. Given a solution where concentration of HO plus equal 5, then negative 3 mole per liter. Calculate the pH of this solution. Solution of application 1. We are given the concentration of HO plus and we need to calculate pH. Then we apply the relation pH equal negative log concentration H3O plus equal negative log 5 10 negative 3 equal 2.3. The pH is without unit. Application 2, given a solution of pH equal 9.2, calculate the concentration of HO plus in this solution. Solution of application 2, we are given pH and we need to calculate concentration of H3O plus. Then we apply this relation. Concentration of H3O plus equal 10 to the power negative pH equal 10 to the power negative 9.2 equal 6 10 negative 10 mole per liter. C.C. Measurement of pH. How can we measure the pH? We can measure the pH of a solution by two ways. Using a pH paper, which is a non-precise method. We will see a video that explains how can we measure the pH of solution using a pH paper. And the other method is using a pH meter, which is a precise method. Also, we will see a video that shows the use of a pH meter. Now using a pH paper, this video shows the using of pH paper to measure the pH. We have sodium hydroxide solution, hydrochloric acid solution, vinegar, juice, lemon juice, Drano, and detergent, and different solutions. These are the solutions, and this is the pH paper. We dip the pH paper into the solution and we compare the color with the color given in this paper. The nearest color indicates the pH. In this case, the color is near to 12, then the pH is close to 12. In hydrochloric acid, the pH is close to 1, between 1 and 2. It's close to 1. And for juice or vinegar, a pH equals 3. And for this solution, the color is near 8. Okay, pH near 8. Lemon juice, the pH is near to 3. Then this is the method which gives an approximate value of pH, not a precise value of pH. Now, how to measure the pH using a pH meter. This is a pH meter. It's formed from apparatus like voltmeter and an electrode dipped in the solution, and the value of pH is noted on the screen of the pH meter. This is the end of part 1.